In 1901, sponge divers made an astonishing discovery off the coast of the Greek island of Antikythera. They found a Roman-era shipwreck laden with treasures from antiquity. Among the statues and pottery, a peculiar artifact emerged, a lump of corroded bronze. This unassuming object, now known as the Antikythera mechanism, would revolutionize our understanding of ancient technology. Initial examination revealed little of the object's significance. It resembled a complex clock, with gears and inscriptions hidden beneath layers of marine growth. It wasn't until decades later, with the advent of X-ray technology, that the true complexity of the Antikythera mechanism began to unfold. The mechanism, dated back to the 2nd century BC, consisted of over 30 bronze gears housed within a wooden frame. Inscriptions on the mechanism's exterior hinted at its function, a device for tracking celestial movements. The Antikythera mechanism, it seemed, was an ancient astronomical calculator of astonishing sophistication. The Antikythera mechanism presented a formidable challenge to researchers. Its delicate gears and fragmented structure required painstaking reconstruction and analysis. Slowly, like pieces of a cosmic puzzle, the secrets of the mechanism began to reveal themselves. Scientists discovered that the mechanism's intricate gear system could track the movements of the sun, moon, and planets with remarkable accuracy. By turning a hand crank, users could advance the mechanism through time and observe the positions of celestial bodies on a series of dials and pointers. The inscriptions on the mechanism's exterior provided further clues to its capabilities. They contained a sophisticated astronomical calendar, incorporating cycles such as the Metonic cycle, which reconciled the solar and lunar calendars. The Antikythera mechanism wasn't just a clock, it was a sophisticated astronomical computer, centuries ahead of its time. The Antikythera mechanism's ability to predict celestial events extended beyond the simple tracking of planetary positions. Researchers discovered that the mechanism could also calculate the timing of lunar and solar eclipses, a feat of astronomical knowledge previously thought impossible in antiquity. The mechanism's eclipse prediction function was based on the Saros cycle, a period of approximately 18 years, after which the relative positions of the Sun, Earth, and Moon repeat. By incorporating the Saros cycle into its gear system, the Antikythera mechanism could accurately forecast eclipses centuries into the future. The sophistication of the Antikythera mechanism's astronomical functions has left scientists astounded. Its existence challenges our understanding of ancient technology and raises profound questions about the true extent of their knowledge. Section 4, a technological enigma, questions across time. The Antikythera mechanism puzzles historians and scientists with its advanced technology. It appears centuries ahead of its time with no known predecessors. How was such a device created when complex machinery was rudimentary? Some suggest it represents a lost tradition of advanced technology. Ancient texts hint at a broader understanding of mechanics and astronomy. The Antikythera mechanism challenges our assumptions about ancient ingenuity. Section 5, Origins of Genius. Where did the knowledge come from? The Antikythera mechanism's origins spark much speculation and intrigue. Some theories suggest extraterrestrial sources or lost advanced societies. While captivating, these theories lack concrete evidence. The Antikythera mechanism remains a testament to human ingenuity and our quest to understand the cosmos. Section 6. Ancient inspiration for modern innovation, the Antikythera mechanism's legacy. The Antikythera mechanism continues to inspire awe and wonder in the modern era. Its intricate design and sophisticated functions serve as a source of inspiration for engineers, mathematicians, and artists alike. The mechanism's legacy extends beyond its historical significance, offering valuable insights into the potential of human ingenuity. Modern architects and designers can draw inspiration from the Antikythera mechanism's intricate gear systems and precise calculations. The mechanism's ability to model complex systems using simple mechanical principles holds lessons for contemporary design challenges in fields such as robotics, computing, and precision engineering. The Antikythera mechanism's enduring legacy lies not only in its technological sophistication, but also in its ability to inspire us to push the boundaries of our own knowledge and capabilities. By studying the past, we can gain a deeper appreciation for human potential and ignite our imaginations for the future. Please don't forget to subscribe and like to grow my channel.